Okay, let's look at simplifying this radical where the index is 5, so this is a fifth root, and the radicand looks fairly complex. Well, we're going to back up and start solving some simpler ones. Let's start with the square root of 4. Now, if the index is not written, it's implied to be 2. You want to think of the square root of 4 as 2 times 2. And since the index is 2, we're looking for pairs of 2 under the radical sign that we can bring out. The question is, what can you multiply by itself to get 4? Well, 2 times 2. So think of a 2 coming out. 2 2's under the radical sign is equivalent to 1 on the outside. So the answer, square root of 4, is 2. What if it were the square root of 8? Well, 8 is equal to 2 cubed, or 2 times 2 times 2. But since the index is still 2, we're looking for pairs. So we've got the square root of 2 times 2 on the inside becomes a 2 on the outside, but there's still a 2 left over. So the answer to the square root of 8 would be 2 square roots of 2. If it were the cube root of 8, so let's look at the cube root of 8. So now since the index is 3, we're looking for triplets. So think of the cube root of 8 as 2 times 2 times 2. We've got a triplet of 2's underneath, so 3 2's as the radicand is equal to a 2 on the outside. And since there's nothing left in the radicand, the cube root of 8 is equal to simply 2. What if it were, the cube root of 16? Well, 16 is 2 to the 4th power. I'll write it out in expanded form here. Again, because the index is 3, we're looking for triplets. So we have a triplet, so we can bring a 2 out, but there'll be a 2 left over. So the answer to this would be 2 and then cube roots of 2. Let's keep going with this idea. Let's put a variable on it now. So what if we had, for example, let's go back to a square root, and we have the square root of 4x squared. Well, again, we want to think of this in factored form, so we've got 4 is 2 times 2, and x squared expanded is simply 2 factors of x. And the index is 2, so we're looking for pairs. So a pair under the radical sign in the radicand means 1 comes out, so we bring out a 2. We can also bring out an x since there's nothing left under the radical sign. The answer is simply 2x. The square root of 4x squared is 2x. Let's keep going with this idea. What if we had the square root of 12, and let's make it x cubed this time. So looking at this in expanded form, 12 is 2 times 2 times 3. X cubed is x times x times x. We're looking for pairs because the index is 2. So we can bring out a 2. We can bring out an x, and that's it. So this would be equal to 2x, and then we still have a square root of, we've got a 3 underneath the radical sign and still an x. And again, since it's a square root, we don't need the index, but let's put it on anyway. Keep going. Let's see. Let's do a cube root. Let's do a cube root of 125 x to the 4th, y to the 3rd, z to the 7th. Okay, so for the heck of it, I'm going to expand this all the way out. 125 is 5 times 5 times 5. X to the 4th, x times x times x times x. Y to the 3rd, y times y times y. And I better make this longer. Z to the 7th. 1, 2, 3, 4, 5, 6, 7. Since it's a cube root, we're looking for triplets. We can bring out a 5. We can bring out an x. We can bring out a y. And we can bring out 1, 2, z's. Z squared on the outside. So on the outside, we'll have 5x, y, z to the second. And then what would be left under the radical sign? We have underneath the radical sign, we don't have any 5's, we do have one x here, we don't have any y's, but we still have a z. So underneath the radical sign, we would have yz. And again, you have to make sure you put that index of 3 on. Now if you go back and look at this, see, if we're looking for triplets on x, you can see that 3 goes into 4 one time with 1 left over. So that's why we have 1y on the outside. Excuse me, 1x on the outside. Whoops, I've made a mistake here, haven't I? I should have an x here, not a y. X and then z. So I've got 1x on the outside, 1x on the inside. And then for y's, 3 goes into 3 once with none left over, so that's why I have a y on the outside with none left over. And then for the z's, 3 goes into 7 twice, so that's why we have 2 z's on the outside and 1 left over on the inside. Okay, one more, and then we're going to go back to our original question. Let's look at the third root of 16 x to the 12th, y to the 16th, and z to the 11th. Now, I don't want to have to write all these out this time, so we're going to do it just a little differently. I do want to think of 16 as 2 to the 4th power, so let me at least rewrite that. And just rewriting the rest of this. Okay, so think in terms of triplets. So we have 4 2's, and we're doing a third root, so for every 3, so would you agree that we could bring out 1, 2, and then I'm going to put down my radical sign over here so I can keep track of what would be left. I'd still have a 2 on the inside. For the x's, we have 12 of them. Well, 3 goes into 12 4 times, so there'll be x to the 4th on the outside with no x's on the inside. For the y's, 3 goes into 16 5 times, so we're going to have y to the 5th on the outside, but we'll have a y left over on the inside. And then finally, let's see, we took care of the y's, we have z. 3 goes into 11 3 times, so we're going to have y to the 3rd on the outside. That's 9. We're going to have a couple of z's left over on the inside. So there we go. That would be the final answer. Let's go back to our original problem up here. We've got, let's see, let me create some room here. So I'm going to rewrite it in factored form. So 64 is 2 to the 6th power, x to the 15th, y to the 16th, z to the 101 power. So let's write down the radical sign over here, and we'll keep track of what would be left under the radical sign. Fifth root, we're looking for 5 pairs. So 5 goes into 6 one time, so there'll be a 2 on the outside, but a 2 left on the inside. 5 goes into 15 3 times, so we'll have x to the 3rd on the outside, no x's left on the inside. 5 goes into 16. 3 times 5 is 15, so we're going to have y to the 3rd, but with 1 y left over. Finally, 5 goes into 101 20 times, so we're going to have z to the 20th with 1 z left over. There you go. There's the answer.